So, in the previous video, we have seen about the theory of principal component analysis. Now, in this video, let's try implementing it. The first and foremost thing is, I said like the data is available in the form of an Excel file. So, I'll try reading it. So, in order to do that, I'll be using same as old story, pip install one pyxl. Right. This is the first step. The second step would be importing the libraries. So as usual, we will be using libraries such as numpy, pandas, and for the plotting, we will be using matplotlib. Then we will be, from the sklearn, we will be importing PCA. Then, as usual, Google Colab say we will import files. And one more thing is, see, since I'm showing like 3D plots, we will be using one more MPL toolkits. Okay, from there I'll be importing something called as Access 3D. So this is an important library which is useful in order to show you the 3D plots. Since in this video, what we are doing is we are trying to take a three-dimensional data and use PCA to reduce the dimension of the data. Hence, in order to make you to visualize how a 3D data looks like, I'll just plot and show you. In order to show that, so I'll be using Access 3D as a library. Right. The second step would be importing all the libraries. These are the libraries that I am going to import. Right. Next is I'll be generating some 3D data set. Right. So let me generate a 3D data set. In the previous video, we had directly an Excel file, and that Excel file I have uploaded. Now, I'm showing the one more option is I am trying to generate some random data where I'll be generating a 3D data. So where I'll be generating for 15 points. Okay. Then in order to do that, so I'll be using uh, np.random.seed. This is the instruction that I'll be using. This section of the code which is used in order to generate random points which are distributed in the 3D space, right? And the feature names that I'm giving it as x, y, z, right? So in order to do that, I'm generating the random data. I'll be making use of numpy and pandas data frame. In order to do that, I have used the instructions like this. Okay. Now let's try to save this file. Whatever is the data that I have generated, let's save that Excel file. So unlike in the previous video, we had directly an Excel file where we read those Excel file and we were able to do the clustering. But in this video, we are generating a data set and we will be saving that data set. Right. So I'll show you that data set. Whatever is the data set that is generated, it looks like this. This is my data. X, Y, Z is my data. Now we will be using this data and we will be reducing this data and to get a two-dimensional data, right? Let's do that. Then the next step would be, let's try understanding whatever is the generated file that we have. Let's plot that to understand how does this data look like. Let's visualize that. So in this case, since I have a three-dimensional data, okay, so whatever those Access 3D that I have downloaded, that will be helpful. So you can see that this is the data points that are distributed in the 3D space. Now let's try applying a PCA to this, right? So I have a PCA with three components. Okay, let's transform that original data into reduce its components. Right? So this is a instruction that I'll be using in order to do that. Once this is done, right? So the next thing is we should be able to plot 3D points with the principal component axis. So this is what we have done in the numerical as well. So whatever is those calculation of eigenvectors, eigenvalues, eigenvectors, and then calculation. So whatever is dealt in the numerical part, right? So the same thing I'm trying to write a code for it. Okay, and I'm trying to visualize that principal component. You can see that. Okay, so there are principal components which are indicated with purple and yellowish color. Then, so whatever is these points, original points, I'll try plotting these, project these points onto these two dimensions, two principal components. So this is what I'm trying to do now. So I'm trying to project these points onto my two principal components with the help of these instructions. Right. So you can keep the numerical aside. So and try visualizing whatever the steps that we have followed to solve the numerical, and you can compare it with the program flow so that you will understand in a better way. So then let's try understanding. Now let's try to plot both original points as well as the projected points. So what did we do till now? So we initially projected the 3D points, then we calculated the principal components, and we did, now we are going to do the projection of it. Okay. So the projection, I'll be trying to use this code. I'll be supplying this code to you. You can try out this code. Okay, so original points are in light gray, and the projected points are in the, yes, the original points are in gray color and the projected points are shown with the color. So you can see that the gray color points which were spread here are the original points. Now after identifying the principal components which are in this direction and projecting all these original points onto the new coordinate system, I'll be able to see these are the PCA1 and PC2 points are spread like this. Now, if you are expecting, like, what is the variance of all three um, principal components, I can print that also, right? So these are the principal components that you can print. You can see the variance like 0.46, 0.29, and 0.23 are the variance ratios. So the total variance captured by the both the principal components is 0.76. So this is how we try to implement the PCA in order to do the dimensionality reduction. Okay, hope you understood this. So this is my PCA implementation part. See you in the next video. Thank you.